Yesterday we made an attempt to define three new terms. Time, we kind of just skipped by a little bit actually, because time is one of those things that, although we know what it means, it's pretty difficult to define, right? Look at a dictionary. The definition for time is not very good. It's one of those ones that your intuitive grasp of time is much better than a real official definition of time. So we won't even bother going there. Speed, however, we defined as how fast something moves. That's easy enough to define. Velocity is the rate of change of position. Now, based on the definition for speed, we can write an equation for it. V is equal to delta d over delta t. Based on the definition for velocity, we can write an equation for it. Delta d with the arrow over it divided by delta t. Given what you see there for speed and velocity and time, tell me which one or ones are vectors. Time, speed, velocity. Yep. Good. Velocity is a vector. We know that because we see the arrow over top of it, right? Velocity is a vector because it has direction associated with it. That means that speed and time have got to be scalars, right? What units do we usually use with time? What are the standard units with time? Seconds. What are the standard units for speed? We can use other units, but if in doubt, go to these units are going to be meters per second, and of course it's the same thing for velocity. One more thing. When we're calculating speed, we've got to know the distance, right? We've got to know the distance. So what you need to do is get the distance in the way that you got it on those 16 questions you had for homework. When you're calculating velocity, you've got to know the displacement. Get your displacement the same way as you did on these 16 questions for homework. Don't just look at these equations and try to do something, some kind of shortcut, okay? You want to find speed, you've got to do two questions in one. You've got to get distance. You want to find velocity, you've got to get displacement, and then you've got to divide it by time. Okay, so don't think that it's going to be just this. Here it is, brand new, just plug your numbers in. Okay, occasionally it might be, but don't overlook what we've already done before you do it. All right. Yesterday we did a couple examples, and we won't go do those examples again, but I do want to draw your attention to a couple of things in those examples. First one says Regina is 600 kilometers west of Winnipeg, and Calgary is 1,350 kilometers west of Winnipeg. What are we given there? Are we given positions or are we given displacements? Those are positions. So if we're given positions, to find displacement, we're going to subtract those, right? df minus di. And then we're going to divide that by t. What about in that example? It says a hiker walks 300 meters east and 1,200 meters west. Position or displacements? Those are displacements. So if we want to find the displacement here to get velocity, we're going to add those together. d1 plus d2. But be careful. 1,200 meters west would be a negative value, right? So it'd be kind of like subtracting because you're adding a negative. Think of it as adding. Get that number, divide by time. I want to do one more example with you today. This appears on page 37 of your notes, of your textbook. So the good news is you don't have to copy this one out. I want you to copy the solution, but not the question. It says, find the average velocity of a student who jogs 750 meters to the east in 5 minutes, does static stretches for 10 minutes, and then runs another 3 kilometers to the east in 30 minutes. What do you got here? You got positions, you got displacements, what do you got here? Those are displacements, good. Now, what does this term here mean, static stretches? Notice I'm not going straight to an equation. Notice I'm thinking about the question here first, right? I'm asking you guys what we've got, displacements or positions. I want to know what some of the words mean. Yeah, he's not moving. So he's running for 5 minutes, and then he stops for 10 minutes, and then he runs again slowly for 30 minutes. Here's what I'm going to suggest you do here. Because there's 3 kind of phases to this, all with similar givens, not necessarily similar givens in terms of the values, but similar givens in terms of what variables we have given to us, it probably makes sense to separate the givens into 3 stages. In the first stage, we're going to say the displacement is 750 meters, and the time is 5 minutes. Not t time, but delta d time. What's t? I don't know. 1:57 p.m. I don't know. Delta t is the time interval. That was 5 minutes that went by. Stage 2, the time interval is 10 minutes. Anything else we have there in stage 2? Yeah, the displacement's 0. Because he stopped. And then, of course, in the third stage, we've got a displacement still to the east, so still positive, 3 kilometers in a time of 30 minutes. All right. Before we write down an equation, before we plug numbers into that equation, what stands out here? What stands out here as being something that maybe we need to deal with before we worry about an equation? Yep. Yeah, that's definitely one thing that stands out. We've got meters, and then kilometers. It doesn't really matter whether you're in meters or kilometers here, but you've got to be consistent. If you're going to go with meters, go with meters. If you're going to go with kilometers, go with kilometers. If in doubt, what did we say to go with? Meters. So let's do that here. 3 kilometers is 3,000 meters. Okay, good. All my displacements are meters now. What units do you think I'm going to get for velocity when I do my calculation, when that time comes? Meters per minute. That's kind of an odd one, isn't it? Could we do that? Yeah, you can, but it's odd. If in doubt, go with seconds. That's what I'm going to do here. We don't have to, but because meters per second is a lot more common than meters per minute, I'm going to do that. 5 minutes is 300 seconds. 5 times 60 is 300 seconds. 10 minutes is 600 seconds, because that's 10 times 60. And 30 minutes, 30 times 60 is 1,800. Good. Now I think we're ready. Now to find the average velocity, we're going to say delta d over delta t, because that's always what we use to find the average velocity. The displacement would be 750 plus 0 plus 3,000. And the time here would be 2,700 seconds, 300 plus 600 plus 1,800. 4. Do the math there, works out to be 1.4 meters per second. And since we define east as positive, we recognize that that means to the east. Right? So by the way, 1.4 meters per second is a relatively slow walk. That means that if this person is jogging for 45 minutes, this person would have actually went further walking for 45 minutes than jogging for 45 minutes and taken a break midway. It's okay, got to start somewhere, right? Does it make sense? You want to find velocity, you've got to get displacement. And this was kind of tricky to get displacement because we had 3 of them. Add them up, divide it by time. If we were given positions, then we would have subtracted and then divided by time. All right, I'd like you to take a look at those 2 questions on page 37 for the next few minutes. Give you 10 minutes or so to work on those, and then we'll take a look at what we need to take a look at when you're finished. All right, question number 2 says, person A runs the 100-meter dash in 9.84 seconds, then takes person B who runs 200 meters in 19.32 seconds. Both of those are pretty quick times, by the way. Okay? Those are both world-class times. Person C runs 400 meters in 1.9 minutes, not so much world-class time. 1.9 minutes for 400 meters. Find the average velocity for the trio and compare it to each individual's average velocity. So what do we really want to do here? Get the average velocity of runner A, runner B, and runner C individually, and then get the average velocity of them all combined. This is one of those questions like our example where we want to break it down into not so much stages, because we don't have something happening and then something happening and then something happening, but we've got 3 different people all doing different things. So let's break it down into sections, we'll say. Section A, Section B, Section C. Section A, the displacement is going to be 100 meters. And the time is going to be 9.84 seconds. In B, we say the displacement is 200 meters, and the time is 19.32 seconds. And in C, the displacement is 400 meters. Oh, this person's running a big distance, right? Once around a track in 1.9 minutes. Is there anything that jumps out at you here before we go and do a calculation here? Yeah, now we could convert seconds to minutes if we wanted, but it probably makes more sense to convert minutes to seconds, right? How do you do that? How do you do that, Matt? Times it by 60, right? What do you get when you multiply that by 60? 144 seconds? All right, so let's get the average speed of each of them now. The average velocity. We're going to see here it's 100 divided by 9.84 seconds. That's going to equal 10.2 meters per second. A lowly 10.2 meters per second. That's still pretty fast. Yep. Oh, 114 seconds? Okay, thank you. Thank you. So the average velocity of the first runner, 10.2 meters per second. Pretty quick. Let's see what the average velocity of the second runner is. Displacement divided by time. Displacement is 200 meters this time. The time is 19.32 seconds. This time we get 10.4 meters per second. Explain that to me. You'd think you're running a 200-meter sprint. You think you'd kind of start getting tired out, right? And you'd slow down a little bit, not speed up a bit, right? Can you tell me why the average speed in a 200-meter might be faster than the average speed in a 100-meter? Good, good. You're at peak speed at about 60 meters or so, and then you're going to keep moving at that peak speed. Now, it might not be quite as peak as it would be to the 100, but you don't have that. You don't have that first phase of the race that's, I don't want to say wasted, but used up accelerating, getting to your peak speed. All right, third one. We know this one's going to be smaller, right? Because this is the slowpoke. We got 400 meters divided by 114 seconds equals 3.51. If you're going for a 5K run or a 10K run, that's not terrible, actually. Like, that's 10 kilometers per hour. That's reasonable. That's about a 30-minute 5K. It's not going to win any races, but it's respectable. If you're running 400 meters, on the other hand, that's a little slow. All right. How do you find the average velocity of all 3 of them combined? What are we going to do? Say 10.2 plus 10.4 plus 3.51 divided by 3? Add them up and divide by 3? No, it doesn't give you the right answer, does it? Let me give you another example to show you why it doesn't give you the right answer. Let's say I drive to Edmonton, 350 kilometers. I'm driving at 100 kilometers per hour the whole trip for 100 kilometers per hour. Except for that 5-minute break that I take in Red Deer. Gasoline alley. I get out of my car, I go stretch, I go get a snack. Get back in my car, 100 kilometers an hour again. What's my average speed? 100 plus 0 divided by 2 is 50. Did you average 50 kilometers per hour on your trip to Edmonton when you were driving for 3.5 hours and you were stopped for 5 minutes? No, you can't just add the velocities up and divide by 2, or in this case, add them up and divide by 3. The average velocity is always displacement over time. The displacement here, the displacement in question 2 is 100 plus 200 plus 400. The displacement is 700 meters. The time is 9.84 plus 19.32 plus 114, which is, anybody have that? 143.16, which, of course, now we do the math, it works out to be 4.89 meters per second. Total displacement divided by time. As much as it's tempting to add them up and divide by 3, it doesn't work. Actually, there is one scenario where that would work. Anybody tell me the one unlikely time that I could actually add them up and divide by 3? Right? If it was all the same time. Yeah, if it was all the same time, that would work. But that would rarely happen. All right? You've got a worksheet going up to you right now. Worksheet number 2 on average speed and velocity. I would like you to complete that worksheet tonight for homework. Questions 1 to 6. With a word of caution, question number 6 is a bit tricky. Don't give up on it, okay? If you're working on this worksheet tonight for half an hour and you can't get it, all right, stop. Fair enough. Yeah, but don't give up on it after 30 seconds because you're not sure what to do right away. Give it some thought. Okay, 6 is a tricky one, but I think you can do it. All right, that's it.